Hello, hello. It's SIG Node Sidecar Working Group. Today is November 15th, 2022. Welcome, everybody. Yeah, this meeting is being recorded. We have, as I said before I started recording, I didn't expect that much interest for this topic. I'm really glad that we have so many people joining. Yeah, today will be it is a kickoff meeting. I hope that we can get some progress. We may not take whole hour, and we'll see how it goes and what frequency you need for those meetings. And I want it to be open forum, so if you want to speak up, just like do it. We need to. I mean, as a working group, we want to have open communication. So I started this document for working group, and I may need some help with filling up charter. For charter, we want to, I mean, why we all here today, we want to understand what will be our goals and what will be exit criteria. I think when we've been discussing it at SIG Node meeting, we said that the main goal for this working group is to come up with a design that we will be approving for 127 ideally. That's why we need to start early, because practice shows that if you start when enhancement starts, then we don't have enough time to discuss all the aspects of it and get all the necessary approvals. So yeah, I think the goal will be 127 design. I don't know whether we will get beyond that. Maybe we'll have so many open questions and so many desire to discuss that we will keep going, or maybe we will just dissolve this group. So I think exit criteria will be at least have CAP approved and work started on sidecar in 127. Any comments on charter? Okay, I posted a few links, and if you're aware of any other documents that may be interesting to share in this context, please add more links. I know so much was produced during this many years. I just failed to put all the links here. Yeah, there are also public talks on like what is sidecar. So if you have those, please also maybe put it in this list, so people who are not familiar with the concept of problem space will be able to catch up quickly. Yeah, yeah, bunch of links. Okay, and now let's go to agenda. I wanted to recap some history of how we get here and why we decided work group is a good timing for work group. So over time, we had some conversations on what sidecars may be, and everybody wanted to solve problem with sidecar. So for some people, it was problem with jobs not being terminated, and for some people, it was that sidecar needs to start early. For some, sidecar needs to collect some logs from init containers. So many problems were raised, and people were trying to address those problems. And it was hanging for many years. At some point, we almost started the CAP going. We almost approved it for one of the releases. I think it was from 119. But at that point, we said that there were two concerns. First concern, we didn't understand what to do next after we will implement the very first step of sidecars. We didn't see the whole picture. And second, we still had a lot of doubts at that time what the final picture will be. And second, our test infrastructure was so fragile, and many tests were so broken that we wasn't sure that if we'll add anything that big, will be reliable enough, and will it break anything else beyond the sidecars. I think at that point, we confirmed both our worries. Like, first worry is that we don't know what it will be. We still don't know, and more discussions we have, more ideas people bring, and these ideas needs to be satisfied, and some designs work better for these ideas and some worse. Like, one of the biggest ideas that I heard recently is security isolation. We need to isolate containers, different security models. So yeah, this fear was materialized, and second fear was materialized about the reliability of tests. I think everybody heard some, at least some talks about regressions that we had after we changed something in pod lifecycle. So we've been fixing bugs and finding so many regressions. It was, I mean, minor refactoring caused all these problems. That is also materialized fear, and I think we are at a better stage right now. We have more people knowing what they're doing, and we went through many regression investigations, so we know where to look. So it will be okay. So it will be it is a good thing to do. So yeah, two fears, they both materialized. I think we are at the better stage right now, and in 1.25, we've been trying to have sidecar containers kept back. At that time we attempted to minimize the scope and make scope so small that it would be uncontroversial, but it didn't pan out as well. So even that didn't work. We truly believe that sidecars are needed, and having sidecars implemented as a hack or as a like surgery placement. Initially, it was an idea to even do it with annotations, to don't change any APIs at all. But all these ideas are crushed of reality. Like we want sidecars and we want to invest into that, but we don't want to put any code that will be partially baked and not clear how to like scale it into full-blown functionality. So yeah, and during that discussion in 125, we realized that we already ruled out so many implementation possibilities that we are at the stage that we pretty clear what we want to do. So maybe forming the sidecar will help us approve some design that is future-proof. So yeah, I can tell what rejected designs were. I have some notes here. So some of the rejected designs was we don't want to do systemd like before and after, like depends on kind of annotation. I mean, there are different names, binds to, depends on. So this was rejected as something that may be needed for advanced scenarios, but clearly not working for sidecar pattern. Because in sidecar pattern, we want to have clear way to inject container sidecars and clear way to recognize that this container is sidecar and this container is not sidecar. So this was rejected as an idea for implementing sidecars. It still may be something that can come up in future as not as a sidecar, as some advanced feature, but for sidecars we don't want to implement sidecars as a binds to semantic or before and after semantic. Second idea was rejected, that we don't want to implement sidecars through different variants like termination of specific container or like restart policy per container. So idea was to minimize the scope to mark that certain container will terminate entire pod, or that every container will have its own restart policy and it will be controlled per container. So you can mark some containers being a sidecar via this characteristics of container, like restart always, even if it's a job, and then terminate if it's not a job. So that was rejected because it's not solving. I mean, yeah, you can read more on this link, but basically, good design of these per container flags implies that there are many limitations with typical sidecar cases. So it only solves very specific cases for jobs or very advanced scenarios for advanced container interoperability and design. So we don't want that. So we want something that categorize containers. And we also discussed that we don't want to implement sidecars as a regular containers that will die faster. So we really need to cover init container scenario. So if we will implement sidecars, the only possibility we implemented is if we'll have init containers implemented as well. So sidecars needs to be able to run while init containers initializing main pod. So that was another rejected idea.
Sorry, sidecar need to run before, after, or at the same time than init containers? What is the requirement there?
So requirement is to allow containers to run while init containers are running. So you should be able to configure init sidecars to cover init initialization stage. And there isn't
like to be ready before init containers start.
So you should be able
cover?
Yeah, you should be able to express the idea that some sidecar needs to be fully functioning when certain init containers are running. So you need to be able to express that.
Okay, thanks.
Yeah, and the main idea is if you want to enable Envoy as a sidecar, then we need to be able to start Envoy before init container starting. Okay. So that was the rejected designs, and I think having these designs, it's getting pretty clear that we want some category of containers, so we can easily inject them. There should be category, and it should be category that apart from regular containers, and something maybe init containers, maybe a part of init containers. So I mean, I think it getting pretty close to shaping its form by just looking at the rejected designs. I also was trying to put up some requirements that we may have for this for sidecars. So if we, yeah, first and foremost requirement is sidecar should not block termination of a pod, even if it's still running. Second is it can start before init containers. Key here is can. I think, I mean, if design will allow it to start, only allow to start before all init containers, I think it's fine. But there is no restriction here. We can, as a goal is to make sure that you can express that they start before some init containers. So like specify which init containers needs to run when. Restart behavior. So restart behavior can be different for sidecars. So this idea is if a pod is marked as never restart, then you should sidecars still should be able to restart because you still need logging, even if it was killed or like crashed, you still want to restart those sidecars. And then when we've been talking about sidecars, like once we introduce this category of sidecars, there may be other requirements that come into play. And as I mentioned, security isolation is a big idea here because if you inject something in customer pod, maybe you want to isolate it. Then resource isolation. There are many examples when sidecars are starving the main container by like taking over all CPU. Pod readiness override. So if sidecar is not ready, then maybe pod should not be ready. That is also was coming up as a requirement and may creep out into sidecar semantic. Liveness and readiness cross dependencies is another variant of that. Like if sidecar is not running, maybe we should say that other containers are not running. That kind of idea. And behavior should be a little bit different. Also, like we don't want to kill sidecars to terminate sidecars through kill when main container is not being terminated by kill. So maybe it's better to kill all kill all the containers and sidecars of whole pod rather than kill all the sidecars and not touch main containers. So that also may creep out in a design. So once we have a concept of sidecars, this all will get into play. And also the idea was to establish a pattern, like we may not address all the scenarios, but and we may not address all the scenarios with sidecars, but there was really big concern of against blotting out pod spec. We don't want to have pod spec updated for every use case. So the idea here was if you will have sidecars that running after init containers, sidecar running before init containers, we don't want two categories of the sidecars, because like third category will be sidecars that are running during init container stage, but like terminating differently, or like not having some restart policy. So we don't want that kind of bloat. We really want to make sure that we have a clear design that covers most of scenarios, and this design is, I mean, it's expressive enough, but it's not bloating into too many moving parts and too many concepts that needs to be explained. So yeah, I think those are requirements I heard. If anybody wants to add something, please do. I think you unmuted yourself, so.
No. I just wanted to, like, my thoughts when you read these requirements is that if we don't want to have a flag, we don't want to have systemd-alike dependencies, and we don't want to only have the termination or restore policy signal when it's a sidecar. I think the only alternative is have some kind of run levels. It can be prefix names like with Tim's proposal, or an int, but I think we don't have many more options to fulfill these requirements. We need the run level route, and we need to follow that route. I think there's no other way that I can see.
Okay.
I don't know what are other thoughts.
If you disagree with the rejected designs, please speak up, because this is my understanding of what we came up with after all the discussions. And I wanted to make sure that we agree that those designs are rejected. Let's work in this assumption. But if I misrepresent something and you feel that you need to reopen some of the discussions, please speak up.
Yeah, so I didn't follow the reasoning for rejecting the systemd-alike before and after designs, because that also feels very well with the requirement number 5, that basically you can express whatever use case you want without bloating the pod spec, because you can basically express whatever. So now that I see that requirement and that design being rejected, I'm curious what was the reason.
Sorry, I was muted. Yeah, so this slide deck was created to explain why dependencies that binds to semantic was rejected. And here I can walk through that really quickly. So today we have init containers and app containers, and one category of containers running before other category of containers. So you can express the same concept like this, but it is a mess of, like, you need to have every container explaining what it needs to do. And if you try to create new init container, you need to make sure that this init container is defining all this binds to and dependencies, which is not trivial. Like it's making injection container into pod spec really painful. You can also express it like that, so it's a little bit better design, because in this design you kind of lining up all init containers. So it's easier to inject one new init container, but it's still, like, injecting app container is still hard to do. Like, you need to make sure that it's defining all those dependencies, otherwise it may start in incorrect fashion. So injector concept was explained here, and then it's much easier to express just two category of containers because you have category of containers init, and then once all these categories completed, it's easier to just start all the app containers. Okay. Yeah, there's more about init containers. Sorry, it's not my slide deck. It was explaining how to inject some app container here, and yeah, it's not very straightforward. Oh man. Yeah, and removing containers also was brought up here. It's hard to remove container. Once you remove, then you need to revisit all the dependencies again, because one container may be blocking other container to start before you need containers, and then before other containers, and then you remove one, and you get a mess of reevaluating all the links. So yeah.
So the argument is there was too much complexity seen for the current pod's development spec.
Yes. And then when we introduce a notion of helper containers, like in this sidecars, so helpers, then we get into a similar situation when we need to, for every helper container, you need to define that it starts before all app containers. And then you may forget some, and it's much easier to just say that helper containers kind of go before app containers. It's a little bit easier. It's much easier to inject this way. Because this is typical design. You typically want all sidecars before all app containers. So you typically will introduce all the dependencies. You will rarely do sequential definition of containers. And this is much easier design to express the same concept, at least for most of the scenarios. And then slide deck goes into more details on run levels. Yeah, so we may have more run levels to solve init problems and stuff like that. So yeah, I think basically the main idea here is that all scenarios that we want for sidecars looks like that, and this is not ideal. Yeah, is somebody?
Hi, yeah, I'm Claudia. Hi, everyone. So I was looking at the slide, I think it's 24. You showed that really quickly, and there is a cleanup container. Yeah, so the question mark is there because it doesn't exist, or for what? Because that's something that actually I wanted to ask to the group if something like the cleanup containers do exist, because I wasn't able to find any of that, like the counterpart of the init containers for something that you want to do once the app containers are completed.
Yeah, it was one of the ideas that it doesn't exist. First of all, it doesn't exist.
Okay.
Express it. There is workarounds, but it generally doesn't exist. The idea here is that once we introduce this different run levels or different stages of initialization, then we may want to solve this problem as well, cleanup containers. And when I was saying that we don't want to bloat of pod spec, that was one of the concepts that maybe we want to express cleanup containers later and define them, but we don't want to, we want to establish some patterns that wouldn't require to have cleanup containers in different, it should be easy to follow the same pattern for cleanup containers.
Okay.
Somebody else?
Hi, so along the, so we have we have sidecar containers, and we have a patch that does ordering during startup as well as ordering during shutdown. So ideally, we want the app container to first terminate and then the helper containers to terminate. So we have an ordering dependency on the shutdown phase as well. So I was wondering if that will be covered in this work group.
Yeah, I will put it as extra requirement here. Yeah, it definitely came up many times.
And for us, the init container, the init containers help initialize the sidecar containers. So when the init container comes up, then only the sidecar container comes up. So initially you were talking about how the sidecar containers would come up first and then the init containers would come. But actually it would mess up our startup order because the init container initializes all the certificate things and whatnot. And then Istio and everything else starts up. So it would be nice if both are separated, like first init container and then sidecar container. And then if someone else wants the sidecar container first and then init container, I wonder if you want to support both cases.
Yeah, that's why I put this like this. Can start before init containers. If I would put it differently, then we definitely losing this scenario, and this is quite common. Like if you have some sidecars that updates, I know, credentials, you wanted some storage to be initialized first, and yeah, you definitely want that. But when we were discussing it, we said that we cannot propose a design and start implementing designs that doesn't have ability to start before init containers. So we need to have this ability, and opposite design wouldn't be accepted. So that's kind of a message right now.
Thank you.
Thank you.
If we're thinking in that many run levels might be needed in the future, should we, like, the only downside that I see with run levels, or potential downside, is that the pod startup latency might grow too much when you start injecting like 7, 8 sidecars to a pod, because basically you're forcing like each run level, the next run level starts when all in the previous run level. So you're basically, yeah, making it as the slower sidecar in a run level. If we're thinking about the future, this might be something to take into account. But yeah, I don't think there's any way around it if we don't want to have more granular dependencies. So it might be just okay to just acknowledge that the pod startup latency might grow a lot. That is out of scope for now, or something like that.
Yeah, I mean, alternative maybe also, like if you want to start some init containers before sidecars, maybe some sidecars can be used as init containers. So if they start and like will never shut down, but then like you will do only initialization on containerization, it may be a good enough design. So if you satisfy that.
But init containers run until completion. You mean to maybe change that too?
You can, like today, the pattern that people follow to start containers sequentially in a single category, like main containers, is they implement pre-start hook, and pre-start hook will block all other containers from running until they complete it.
Right.
So that's a design.
Okay.
So yeah, we may, like, let's say we only have run levels that is pre-init containers, and we don't have then one of the pre-init containers, we may design in such a way that pre-init containers can be authored such a way that it will become init container almost. It will not complete and like maybe live in for a long time, but at least it will run before, like initialize before any other sidecar containers. So that may be another alternative design. But yeah, I'm not sure what's better. Have init containers that never end, or have pre-init containers, or like have 2 stages, pre-init and helpers containers. So that is one of the open questions. But yeah, I think main point of this slide deck was that all the helper, like all the sidecar scenarios, typically looks like that, and the much better way to express this is to do that. And I would agree with John saying that sidecar can be injected by webhooks. I think it's coming up all the time. So let me add it as a requirement. I think keyword here is reliably. Okay. Yeah. I hope it answers the question why this was rejected. Is there any more questions on either requirements or what was rejected already?
Just for argument's sake, one could argue that having n levels, right, run levels is still a graph. It's still a dependency graph. It's just more linear.
Yeah, it's kind of opinionated dependency graph. You can only have those.
So if you needed more, you'd have to do something else, like plugins in the container runtimes.
What do you mean something else? Something else like
Well, if I've got two init containers or two init tasks, right, and two cleanup tasks that have to go in a particular sequence, right, one before the other, and then on destruction, the opposite direction, right? How would I do that?
So if do you mean if we have cleanup containers, or you mean if we have pre-init containers that need to?
Yeah, if you've got pre-init and you've got init, and then you've got the cleanup. One could argue if I'm going to have pre-init and init, then I need cleanup and post cleanup.
Okay,
right?
That's fair.
You see and then if I've got two sets of, one, if I've got a dependency between two of the containers in the init and the pre-init, then I would need another level, right?
Okay.
Which basically you're just walking your graph out into a long line, a long dependency line. As we find out, we need more run levels for argument's sake, right? It may seem that we're making it simpler by not having a graph, right, with two dependencies on one, but really we're just making one long linear graph. For argument's sake. I've been here before, Sergi, right? 40 years. It's nice to have it simple and the graph to be linear, but somebody's going to say what if, and there will be what ifs. We're going to have plugins in the container runtimes. There will be ways to do other ways to do resource management, for example, in a dependent way.
Yeah.
Or any of these containers, and right.
And it all goes back to a question: what we as a Kubernetes want to orchestrate, and what customers will need to implement themselves. So even today, people get very implement very interesting solutions with even like 2 stages of init and containers, and implement all sorts of cleanup tasks with hooks. So it's just how much of it we want to take and express as a Kubernetes, and how much of it we will keep for people to implement as a code. So that's a big question, and I understand that it may blow up if we will decide that we want to support all the scenarios. But if we will only support very generic pattern and then let people use this pattern to implement more elaborate scenarios, and I think it may be fine. Okay, I think we have 20 minutes left. I think we need to understand how to proceed on that. We need to come up with a write-up, what exactly it will look like. So I would suggest, I'm sorry, I am not catching up on chat. If there is something that needs to be discussed, let's, Roderick, do you want to discuss hooks? Sorry.
No. I think we can continue, but I was just, we can have that question in the background answered by chat, and I think it's fine. Thanks.
Okay. So I think people mean pre-stop hooks that will be used as a cleanup for container, but it's not reliably working. Yeah. Okay. So yeah, I suggest maybe we can brainstorm on some ideas right now, or maybe we can start brainstorming and understand what we can prepare for the next meeting to have a better understanding. Like, first of all, is there anybody on this chat who wants to write up, like, who understand all these requirements and see a clear picture how it should be implemented? I'm not raising my hand, by the way, so I still don't have some reservations. Okay, maybe we can try this mental exercise. We will take this picture and like have one stage and try to advocate what will have the stage, how it may look like in pod spec, and what will be basically how we whether it will satisfy all the requirements. Work this way. Let's start new slides. Okay, so let's say we have only this. Okay, keep it deleting, almost there. Okay, let's say we only introduced pre-init containers in 127. Does it satisfy all the requirements?
Do they terminate before the init containers, or do they have a termination like init containers?
Let me answer that after I will figure out how to do a screenshot. Okay. Okay, so the question was, if we have this design, how do you pronounce your name? Ramya? Ramya is good? Okay.
Yeah.
Terminated sequentially. Yeah, I don't know. So if we have, like, let's say we have category of containers called pre-init. They, I think idea would be that they start before all the init containers and they run through completion of like entire pod. And they will need to, probably they will need to terminate even like, they wouldn't block pod termination. I think that would be a requirement for them. So if we have that, do we need to ordering? So I think biggest promise Kubernetes can make is to terminate them after all app containers terminated. So that will be clearly promised. Ordering of termination is rarely guaranteed in Kubernetes. I don't know whether we want to do it in this cap. Like, let's say we have a termination order. Like, even if we will try to do that, we still, yeah, I don't see how we'll do that. Like, typically, we don't do it today.
But if, okay, so I go. So if we don't guarantee that pre-init containers will be terminated after app containers, then service mesh use cases, for example, will not work because the service mesh might be terminated before your app. So the last request won't work. So I think we don't necessarily need sequentially, but we need termination dependency between pre-init containers and the rest and app containers.
Also, if we only have
No.
pre-init before init, it won't satisfy number 2, where it's can start for init containers, because in this case, they only start before init containers. We don't have the possibility to start them after init containers.
So if we will,
What do we say? What does it mean that we ensure that they stop before X container? Does it mean that we signal the SIG term after we verified that the process has exited? Because there's a very big difference between guaranteeing that we signal them in different orders and guaranteeing that we send the signal only after the app has exited, right?
So right now, the way the lift patch works is we signal the main container, wait for the main container to terminate, and once after the main container is terminated, we started SIG killing all the Istio and Envoy sidecar containers. So we actually wait for the main container to shut down.
Yeah, so that's what we have right now too. But then we have a workaround this behavior that we don't really want, that basically allows us to send the signal to the sidecar, because we want the sidecar to know that the pod is shutting down, so that it can start draining the ingress listeners, because some gRPC clients, for instance, will try to reconnect otherwise. So all I'm saying is it's not always obvious the exact ordering you want, or at least I want the sidecar to know that the pod is stopping, because
Exactly.
this might be responsible for draining the ingress traffic. I understand that it needs egress to work, but the ingress needs to start draining.
Yeah, exactly. You need in the sidecar to know that the pod is terminating, but the termination order of the container is actually the one suggested. So there might, like, what that means is not that the order is not that necessarily. What that means is that we may need, for example, another hook, a termination hook or something like that. So, and sidecars that need to drain can define the termination hook and say, okay, call this script as we have restart and pre-stop hooks. But we don't need to change the termination order, because in fact, you want the termination order to be the same in that case too. Otherwise, like if you kill the network before the other containers, then they won't be able to respond to requests, for example.
Right. But again, I'm not sure Kubernetes makes this kind of depending on the, like, you're suggesting we add an extra way to signal to the sidecar that it is stopping instead, on top of sending it SIG term. But if you just send SIG term to the sidecar right now, in our context at least, we would have zero problem. The sidecar knows how to stay alive for the duration of the grace termination of the pod. I don't understand what's the actual need for this ordering to be done by the kubelet itself.
John?
Yeah, I think the issue is that you don't want the sidecar to stick around for the full termination drain period. Like, for example, what if I set it to an hour? Because sometimes my app takes a really long time to shut down, but other times it just takes 10 seconds and it terminates, right? If you just wait for the entire drain period, the whole pod will be stuck around for an hour, right? We want to be able to optimistically shut down as soon as possible, but be able to live up to as long as the grace period, not always live that long.
Okay.
So John, do you mean terminate, like exit sidecars when app containers are still in grace with termination, or?
Yeah, I mean, once the app container is done, at least for like the service mesh use case, there's absolutely no reason to run the sidecar, right? It's useless without the app container, so there's no point keeping it around. So we want to exit exactly once the app container is done, but no earlier or no later.
But going back to the signal about the termination, do you want sidecars to be notified when we like after their termination? So like we send signal to app containers to start terminating, and they enter this like pre-stop hook. Do you want to start sidecar termination at that point, or you want to wait till exit and then start termination?
That's a good question. It might be kind of nice to have two levels of signals, because like what we would probably do in that case is once the app container started shutting down, we could start sending like go-aways to responses to the proxy. So we start kind of draining connections. Then later, once the app is drained, either send another signal and we'll shut down. Maybe it's sig term first and then sig kill later. Maybe it's something else. I don't know. But it would be kind of nice to have, I suppose. I mean, we could still handle it. It would just be a bit less graceful if we didn't know when the app was starting to shut down.
But do you see like it should be a signal that is sent, or maybe a hook, like a termination hook, and execute this? Because the thing with signal is that is no standard signal right now to use for that. And if we go into sig term and then sig kill, as you suggested, then you're killing the sidecar in kind of a violent way. When
yeah, no, I mean you're absolutely right. I don't have a good answer for that.
Okay.
Also, if we did a signal, wouldn't it be on the developers to essentially capture that signal and do the graceful shutdown, as opposed to like having a hook?
Okay, so signal is better.
Well, I was saying the hook might be a little better, just because a signal would put it on the developers to capture that signal and know what signals can be happening. Like make it. I mean, essentially, you have to make it communities aware, which I mean, you kind of already are doing that, but it's more tied to Kubernetes implementations.
Okay. Yeah. Looking at time. I think I want to discuss this like initialization pattern and whether we can initialize, like use some pre-init containers that live through the duration as actual init containers if you need to do them earlier. So if we will have some startup sequence that like we guarantee that some pre-init containers will not, like one pre-init container can block start of another pre-init container. Will it be enough for this number 2, or we clearly need this like specific init containers to run to completion, and then everything else runs? Is there any thoughts about it?
What I don't follow about that is that requirement number 2 says can start before init containers. And here the concerns are like if they start like on the graph in the chart in the drawing is starting before. So I don't see why it wouldn't satisfy number 2 because it's starting before. What am I missing?
So we wanted init containers to, we wanted the pre-init containers. Pre-init containers might have dependencies on init containers in terms of certificate issue and all that. But we can just move all that initialization into the pre-init container itself and then start the main process in the pre-init container. Actually, the difference between init container and pre-init container is kind of like converging in the sense that the only difference between init and pre-init is lives for the entire life cycle of the pod and not terminate after the pod. So what I'm trying to get is like, if you depend on initialization scripts on init container, you can just move that into the pre-init container. So point number 2 may not be a blocker.
But can you always move it? Like if you have some certificates, like SSL certificates that a different init container is doing, like can you move that logic inside a completely different container that needs them? I don't see, but maybe I'm missing something.
I think it can be moved, but I'm not thinking fully, like I'm not having the full picture.
So let's say you have some certificates in some vault, you have some vault init containers and some sidecar pre-init container that needs those certificates to run. How would you move it? You will need to create a combined container image that has.
So the init container is just a script for us. So I would execute those scripts, and eventually init containers typically end. So I would wait for those to end and then start the sidecar container process in the same process namespace.
So for us,
Right, but you need all the dependencies from the init container. Like you need to create it's not clear for me at all.
Okay.
Like,
our use case, I think, actually matches up with what you're saying, Rodrigo. We have 2 primary sidecars we use a lot. One is providing identity services, spiffy stuff, emulated IMDS, just things of that nature, like you're talking about, and mostly serves it out over a localhost bound server to other containers in the pod. Then we also have a sort of service meshy sidecar, but it's getting certificates from the sort of identity sidecar. So like ordering, we need the identity one to be there, then the service mesh one, then anything else. So sort of, a proposal that just has a single set of like a single phase for enveloping containers, whether it's called pre-init or whatnot, would still sort of not necessarily work super well for us in that use case, because we do have that, 2 different enveloping sidecars around our app containers, that have dependencies on each other. So we need at least like two phases there for how we use them.
Also, the reason why I said it wouldn't satisfy 2 is because the wording of 2 is can start before init, but that also suggests can start after init. But in the case of, like in the graph specifically, we wouldn't be able to start pre-init after init. But if that's not, if people are saying that we can kind of move things around and move logic around, it wouldn't be a blocker, then my point isn't really valid.
I extended this requirement to allow init-like behavior before sidecars, so that maybe clarifies things. But yeah, Rodrigo, to your point, it will not be it's not a trivial rename of init container to pre-init, because behavior is different. You'll need to move code around to actually code. So looking at comments in the chat. Okay. So yeah, we have 2 minutes left. I think it's a good mental exercise to go through this picture. I really surprised that most discussions were around termination of sidecars rather than on initialization. I think are people fine with this time for next week to continue discussion and like get to the specifics and maybe write something down? Is this time okay? Okay, I see 1 thumb up, 2 thumbs up. Yeah, next week is a shorter week because of Thanksgiving in the US, for US people. Yeah, if you cannot join, we will record everything and write down all the notes. Yeah, Mike comments that no changes to CRI noted so far. Yes, there is no changes to CRI. I think one difference for CRI and for that may be interesting that I'm thinking about is if we have this pre-init, init, and then app containers, CPU manager will be very tricky to implement. So CPU manager will need to think about pre-init and app containers, how they will allocate CPU with NUMA kind of closer to each other, and know about those, know about think about how it will run in future, but then run on some other CPUs for initialization stage. So it will be.
Yeah, do we have an annotation so we can identify the classification of the containers? I can't remember.
We don't have. Yeah.
Yeah, we might just need an annotation, and then we can pass that to the managers.
Mm-hmm. No, I will try to copy chat. So let me send an invite for next week, and we will continue the discussion. Thank you everybody who came here today.
Okay. Cheers.
Bye.
Bye.
Thank you.